Hello folks, we're going to put this Gecol to one side again. That's the second big session we've done on it. There's no promise that's going to ever work, but we keep picking at it. Let's put all that to one side. We could have done a part 1 and a part 2 to that. We've got a Uniden today, Uniden 200, and it should be a retune and test. We've got the original mic with it, and I've said before, these are very muffled and lacking in treble. We'll be using a standard replacement mic, and when we do the on-the-air test, then we will demonstrate both. So it's great to have those Uniace originals. Oh, it's a 100. I thought it was going to be a 200. It really doesn't matter. They're exactly the same set. That's in nice condition. He says he's done the usual 4 capacitors. I won't show the original person's address underneath, but it's come from Suffolk, Southwold, Suffolk. 3300141, and it's such nice condition. I think we'll use our duster. Mr. Trucking and Farming collected all his sets yesterday. We kept one back, and that's one of his audio line bases, and there's quite a few new sets from them. There's 3 of them are President sets, and so we'll be getting on with those, interspersed every other with other customer stuff starting tomorrow. I don't know which we're going to do first. We'll find out. Right, so because he says he's done this, I'm not going to open it up till we've done the little performance test. And there's something else. This gentleman is the person who we did the last Murphy base station for, and none of the meters works on that Murphy base station, and he's actually done an interesting thing. I'm not a modification lover, but he's done a modification because there's no hope of getting those meters. You could buy 10 of those sets and none of the meters are going to work. We're actually finding now it's 1 in 5 is what's working on those, and it might be 1 meter, not both meters. And you often see, when you see them for sale, you'll see the meters jammed in the halfway position. The meter lamps destroyed them. They were never intended to be backlit. They're 40 years old. They were cheap and nasty meters. And before I carry on opening this, doing the tests on this, I'll tell you what, I'll just go and get a photograph to show you what he's done. So there we are, that's the Murphy as we know it. That's just taken, that's a video still. I went into Google, typed in Murphy CBH1500, and that's actually a photo of one of my on-the-air tests. And as you can see, I'll tell you what, we'll just zoom in a little bit. I'll press all the right buttons. And if you remember, you've got these 2 meters. One of them's S and RF, and the other's an SWR meter. So I'll show you what he's done. I'll just fold the paper so it doesn't show his letter. What he's done, he's put a blanking plate in and put the kind of meter which you have in the mobile set, and that's with it off and that's with it lit up. And I thought that's a really good idea, because there is no hope of getting the original meters on these, and you know, there's a lot of these type of sets. This is a Midland 100M. A lot of these illegal radios. Let's put the zoom back where it should be. This is a Midland 100M. This isn't a good example to show you, but they have obviously got a meter on them. This is a broken meter, but there's so many of these around which are for the American market. They're illegal sets, can't be used here, and so they're a good source of spares. And we had the socket off this for that Grandstand Gemini, waiting for a part for that because the bar graph driver failed. So then you'll get the on-the-air test. But these have meters, and what a good idea. And do you know what I'm going to do? Next Murphy which comes into my possession, I'm going to send the front panel up to our friend Gareth in Leeds and ask him to make an adapter plate to fit the Maxcom type of meter, which is so prolific on the scrap market. And we'll do one like that. I think that's a really good idea, so well done that man. So it turns out something with nothing of a meter, and you can make a nice job of that. So there we go, that's the Murphy discussion. So now's the job in hand. I need another clipboard. That's our standard replacement mic. I'm expecting this to be just a retune and test. So for those of you who don't know, the Uniden chassis used in the Uniden, the audio line, and two of the realistic sets, and the two base stations, the Uniden 300 and audio line 345 base stations, is less sensitive on receive than the CyberNet chassis and most of the other chassis, and they're much loved because they are much better for not getting bleed over in a town/city situation. So some of that can be to do with sensitivity, and some of it of course can be to do with a better design, but they've suffered from a poor choice, and people don't know this when they manufacture, what turned out to be a poor choice of capacitors which failed 5 years later. Well, now they're 40 years old. If you change some of the capacitors which are problematic, then your problems have gone away. So one of the things which happens with the capacitors is the display won't light. That's a telltale. So I'll tell you what, let's start at the top of the sheet. We'll plug our extension speaker in, drop one of our pairs of glasses on the floor, and this is immaculate condition. Let's see if PA works. I don't think you can control the volume on PA. 1 2 1 2 1 2 1 2, testing 1 2 1 2. Okay. Well, that doesn't work. I'm going to turn this set off. In case it's dirty contacts. Testing 1 2, testing 1 2. We've got no audio. Right. Okay. So PA doesn't work. Right, we'll plug into extension speaker, see if we get a hiss. It's like the squelch. You see when you switch it on, we got the squelch coming in, didn't we? It's like it's on full squelch all the time. Right, we'll put the test set on. I thought this was going to be a breeze. Right, set the signal generator 79125. Okay. So what we got? Well, S9 is as the calibration should be. Turn the right down. It's correct. That's working. Right, start with transmit then, even though we've started with receive. How funny. So the squelch is too high, it never hisses with squelch at minimum. Tell you what, we'll do squelch sensitivity while we're meddling with the squelch. So minimum, so I've got squelch to absolute minimum. Let's go to the attenuator. So the minimum squelch is 5.1 microvolts. And the maximum squelch is never opens. I put that in the wrong box. We're not going to get far with sensitivity because what's going to happen is the squelch is going to come in. Let's look at transmit. We'll come back to receive. I think we're on low power. Yep. 3.1 watts. Uh, 3 watts on channel 1. Channel 40. 2.9 watts. It's kind of balanced for what there is. Low power, which is adjustable on these, 170 milliwatts. Back to full power, and the current consumption is 743 milliamps, which is good for that output. Deviation on this test set, wallow. Either we haven't got any, testing 1 2, there is no audio. That's why PA doesn't work, isn't it? No transmitted audio. I've anticipated that, haven't we, recently? Frequency. Test gear's been on plenty of time for this to be accurate, and it's not adjustable on these radios. 2779148, it's high, which is okay. I don't know why it's high. It's high. Right, let's look at the receive. I'll now dial in that slightly higher frequency. It's all within spec, this, so it doesn't matter, but it's just strange. So we now need to plug the extension speaker, which goes to the test instruments. I can hear the internal speaker working. think we need an earth on these. Yeah, because it's an isolated chassis, not negative earth. Right, let's go to the SiNAD meter. Well, how come the squelch is staying in? It is, actually, it's better than they usually are. 0.4, it's about where Maxons are, 0.48. Zero 0.41. It does 20 and it does 20 for 2.7 microvolts. Sounds like the detector could be out. The RF meter on transmits. Go back to transmit. He's low, but the power's low, so that's fair enough. The socket. I'm not going to tick these off because I haven't got to the bottom of what's happening. Let's take the signal generator off. Well, now the squelch is acting. What on earth's going on in this set? I do know he said something about a dodgy red wire. Well, I think we're going to be having all the lids off this set. We'll start with the speaker lid. Now we will be doing the VCO, but we won't be doing it. We won't be doing it first, even though that's bonkers. I need to have a service manual for that because I don't remember. Get on with the transmitter. We'll do some basic tune-up, and then I'll go and have tea. It's that kind of time. So he's done those 4 capacitors. I will just need to check 470, 470, 220, and 220. And he's put 105 degree temperature rated ones in, which is the best thing to do. Well, it looks, it looks a very genuine set, that. So we will have to look underneath, but this customer will have probably done the isopropyl alcohol because he does that kind of thing. He's a ex-computer to component level engineer. So we're not going to do the VCA because I can't remember at this stage, but we'll go over to do the transmitter. Right, here we go. So we want centre of peak. I'm going to have to now already change scales. all those were spot on. So the next one is this one. And that's probably going to be spot on as well. And the power set on the final one. Yeah, that's so this one is the power set one. As far as this goes, it's never been touched. And there we are, 4 watts. It should be within the 0.1 that we are expected to be able to get between the band edges. So channel 1 is 4 watts. Channel 40 is 4 watts. So that's worked out right. That makes a change. 4 watts, 4 watts, 4 watts. It was pretty balanced before, and it's even more balanced now. So channel 20, we're now drawing 905 milliamps. It's still under 1 amp. Use one of those 1 amp power supplies that were going around at the time. I mean, the bench power supply is 2.5 amps, and we don't have anything that goes more than 2.5 amps. But it was a bit little having those 1 amp ones. It wasn't Taran, was it? It was FKI who did battery chargers. So current's 905. Let's do low power. So now it's 140 milliwatts, which was even worse. So these are labelled, and it's the one that says low power on it. Now, why is that so far out? Unless somebody thought that's the power preset. And while we're at it, we'll do the meter for the front panel, which is there. We'll also go to full power. That's actually come up to where it should have been. Hardly had to touch that. So we've now got 400 milliwatts, and we now can tick that off. It's in the centre of the red zone, centre of the strawberry patch. We've got no transmitted audio. That won't have come right. 1 2 1 2. So here's one of the little tests first. I'm going to carry on and do the receiver because this isn't going to be an insurmountable problem. It can be one of these capacitors shorting out the audio. This is used as a speech processing and preamp, this chip here. So it's, again, without the manual, it's all guess, isn't it? But let's just poke my fingers on the pins of the mic. Nothing, as you'd expect. And remember, it doesn't work in PA. This is deviation down here. So let's put using a metal screwdriver, I've got my finger on it. So we've got a click. Can you hear that? I'll just turn the volume up. So you can hear that it's capable of transmitting beyond the deviation control. So what we're going to have is capacitors around this speech processor chip. One of these capacitors, or more than one of these capacitors, has failed. So we'll look at that with the service manual. It can also be the IC that's failed. So much for this being a retune and test only. Let's move on to the receive. We'll get the set done. So put 100 microvolts on the signal generator, and I'll show you the oscilloscope. We'll put enough volume on to get a sensible waveform, and I suspect the detector is going to be very slightly out. Well, that was very, very slight. I'm going to have to alter the meter sensitivity because I need to see the meter whilst I'm doing this tune-up. I need to look at the meter, the oscilloscope and my SiNAD meter. We'll go over to the SiNAD meter kind of simultaneously. It's like playing the organ and playing 3 lines of music, right hand, left hand and feet. Because I've got to make sure, looking at this meter, that I'm on the right peak whilst making sure I haven't got a horrible waveform on the oscilloscope and making sure my SiNAD is getting lower as I tune. That's the one that's out. That's the one that's out. I knew something was out in the IF. That could be why the squelch is funny, or it may not. Right. Of course, we now might have got worse sensitivity because I fixed the IF problem. I've forgotten whether that's transmit or receive. I'm going to go back to transmit, show you the other meter. It is transmit and it is correct. Right, back to receive. Now looking solely at the SiNAD meter. Let's just drop the signal a little bit. Let's put it to about 6 dB. We've gained a fraction there. That hopefully will compensate for the IF being out. We've gained a fraction. I'm going to drop my signal back to 6 dB. We've gained a fraction there. That was absolutely spot on as it was. So I'm just going to do this again because there is some interaction between. No, nothing. No, we're spot on. That's it. We're done. So we'll look at a new SiNAD reading. So these sets are usually only just under 1 microvolt. So it's come in doing 0.48. And it's now 0.45 despite the IF being wrong. Because you can get a false reading because it's got strangled audio if the detector and the IF's wrong. You can sometimes have the set looking like it's more sensitive, but the clues here, I think this will have improved dramatically. In other words, the clarity when it's got a whacking great big signal. 0.4, make sure I'm absolutely right, 0.45 microvolts. I know it looks like we're skirting around the edges, but we're not in this case. 0.37. This is very good for this chassis. It's exceptional. 20. Well, we still can't get it under 1, but it's now 1.7, which is blooming sight better than 2.7. And hopefully we've got the squelch. Well, the squelch kind of started. Let's turn this to standby. Let's get this squelch sorted once and for all. Turn the squelch to full. I've got the I'll show you this. Got the attenuator on at 6. What am I talking about? I've got it on at 100 microvolts. And what I want to be able to do is for the squelch to open. I've got it on full squelch. Remember, it never ever opens. So squelch is, it's going to be that one. There we are. So it doesn't ever open at, I'm not even on. Let's try again. No, it doesn't open at 100 microvolts. Nobody says it has to either. No, this has an issue. So we're at full squelch, and we can't get full squelch. So turn the squelch down. So that's full squelch preset. That's minimum squelch preset. Let's put 100 microvolts on, turn the squelch up. Yeah, it's bombing out halfway. So it's got, although the sensitivity we've now got, on the face of it, we've probably got the sensitivity okay. Just set squelch on the radio. Yeah, it's usable. It's not brilliant, but it's usable. It's 1.8 microvolts. I'd like it to be under 1, but it's 1.8 at the moment. But I think there's an issue because we can't set full squelch properly. Could be capacitors as well. So we've got dodgy squelch. As I say, most people say that's fine, but I know these sets are capable of better. If I'd never seen one before, I'd say, yeah, that's fine. I wish that Gemini worked as well as that, but I know that's not faulty. Whereas this is. So, with two things to tackle, we better take. I'll take the test instrument away. I don't think we will need that, but no, we won't, because I can do the squelch by ear. We'll go to the speaker mounted on the wall, which is a bit easy to work with when you've got the set-in bits. So, I mean, the work he's done on that is absolutely flawless. So I'm going to have my tea. We'll come back to this, and with two faults to address, we'll start with the no transmitted audio, and then we'll work round to the squelch. Right, so I've got the realistic 2000-2001 service manual. So this is the 2001. The chassis are electrically the same, but they're a different layout. So, you know what? That's for the Murphy base station. Daft as a brush, I tell you. Very, very similar circuit, but a bit faded. When I paid $16.99 for this manual from Tandy's in 1982, I received a photocopy. This is a good quality scan of the photocopy, but it's not like having the original, is it? No, Mr. Tango, it isn't. So here we are with the audio. Camera 1. So it couples into stage, looks like capacitor 92. Capacitor 92, 95, something like that. 4.7 microfarads. We'll put 92 for now. It couples with, looks like 2.2 microfarads, 98. And 81. It looks like 2.2, and 81 also looks like 2.2. So let's just check again. We've got an audio input. Oh, we've got it couples at capacitor 75, 4.7 microfarad. And that's where our deviation control goes. So it's actually shown the opposite way around. Our mic's on the left, and our outputs on our mic's on the right, and our outputs on the left. It was the other way around on the Murphy CBH1500 chassis. So 4.7, .7, 2.2, could be 22. There's actually another one up there, 98. It looks like there's 5. Let's get the power off this. So chances are, I mean, these are all, apart from 75, let's see if we can find them on the board. 91, 73, 98, 95, 81, 77. It's quite difficult, isn't it, to read that photograph. I've probably got a better one on the computer. I'm going to go and amend. I'm going to go and amend this. I'll do it from the computer screen. See if I can find a better scan. I think we've got one which wasn't in the service manual, but actually came with the set. Right, we're now 40 odd minutes of research into this. It's what you have to do. So we've got 2 circuit diagrams here. One's the same as I've out of my manual, but straight off the computer, and that's this one. And then we've got one from another source, and you see the focus isn't quite there with that. The focus is better with my one, but it's less distinct. So I think between them we're going to get the right parts. I think we'll put the camera back to normal position. And then we've got the layout here from the bottom, so we can find the parts on the print if we need to do that, and of course from here. So when we look at here, I've left my notes back on the computer. If we start again, the first one is going to be resistor 75. Let's look at the other one. Resistor 75. Oh, it's 4.7. 4.7. So we can't see the 4.7. We're having to run between two, aren't we? So let's just make sure that 75. This is going to be hours long, isn't it? 75 is 4.7 25 volts. That's our first one. I'll tell you what we're going to do. We don't normally do this. We're going to try it after each one, because there's no point in spending more of the customer's money than we do, but we'll start at the deviation control end and work back towards the mic. So I pulled a few out which I'd remembered. There we go, 4.7. So resistor 7, capacitor 75, if we look at the layout, is this one here. That one there. That one and that one. I've got somebody who sells microphones trying to get me to demonstrate them on my channel. Have you seen that? I've even forgotten what they are. A lot of people use these wireless microphones. I've got 4 Shure SM57s in front of me, so as I turn on the bench I'm going to be more or less picked up, and to some extent it is stereo. And how much are SM57? 58, isn't it? It's the vocal type mic. 57's the instrument type mic. They're over £100 each, and they are a dynamic microphone of a well-proven type. So why did they think... I thought they were trying to sell me push-to-talk microphones because we service two-way radios, but I think they wanted me to use their microphones for the videos. And I see these a lot with people who have a wireless tie clip mic type of thing. I can't even remember what they're called, so that was pointless telling you it. So I said to them, you don't get replies, I think this is all automated. It's like I've got Nikon wanting me to show their cameras. Well, we're using Sony cameras. I said to Nikon, you don't do camcorders. We only use camcorders. I don't use stills cameras pressed into service as camcorders. They might give a good picture, but my kind of thing about that is if you're running them for hours and hours and hours, they're not actually intended to do that. And so I think you have failure not lasting 25 years type of thing. Now Nikon did camcorders in the 90s, but there were Sony ones which were just slightly different and said Nikon on them. And of course they've got the same capacitor issues that Sony was landed with by using the SiNAD capacitors in those camcorders. So there you go. If Nikon can't be bothered to make camcorders, I really don't want to use stills cameras. So there we go. They don't look at the videos, do they? They just think, oh, you've got 10,000 subscribers. Oh, well, we'll have a bit of that. Well, they're not. Right, so we've done that one. So we'll switch it on. This is going to be fun. Easy. Do you know what? The easiest thing to do is to put our speaker into PA, because when we tested it and there was no PA, that was why, wasn't it? Let's put the power back on. Switch to PA. 1 2 1 2. Absolutely nothing. Of course, it might be the chip. We're working towards that. Right, switch it off again. What it doesn't do is any harm. I don't want to do a full recap because it's costly, isn't it? It's not the fact you need like £8 worth of parts, it's the time. So our next capacitor in the line, we've done 75. Let's look at what couples the output between. So I'm now going to work from the other end. So our output from the first part of the chip is there on pin 1. It looks to be 2.2 microfarads. It looks to be capacitor 94. So let's go back to the other diagram, see if it's a bit more distinct. 96, 4.7 microfarads. 96. .96 is that one. So if that really is 4.7 microfarads, let's look at the manual. 96 is 4.7 microfarads. So we'll get that out. And I'll go and fetch another capacitor. Not that one. It's that one. We've got a couple of JWRs coming today, and they will be Monday. Tomorrow it's a box set from Mr. Trucking and Farming. Well, that broke getting it out. I hadn't unsoldered that well enough. But who's bothered? Yep, 4.7. So we'll clean those holes up. This could be a situation where we need to solder it to desolder it. That's come out. Right, I will go and get another capacitor. I just asked Mr. Chippy what those microphones were they were trying to get us to promote, and it was Rode, RHOD, is it, with a funny O in it? Anyway. I don't think they do dynamic mics, I think it's all ones with circuitry, which aren't like... I honestly can't see they're going to last. Mind you, I don't think I'm going to last another 25 years either. See, I don't buy anything that I don't think is going to last 15 years. Or some kind of discount if we did a promotion. But I don't know how much they cost in the first place. Anyway, where do I get the money from? I need to play the organ for a lot of services. Right, so that's the next one in. So the idea is we're going to change all these capacitors that couple. I think there's 3, well, not the ancillary ones, and then we'll presume it's the chip that's faulty. But of course these capacitors can have caused the chip to be faulty. 1 2 test 1 2 1 2 1 2. So we've still got no audio. So there's a third one, isn't there? Yes, Mr. Tango, there's a third one. So we've done let's just see, we did that one. We did 91. No, we didn't. We did 96, which couples there. And then this one's absolutely paramount. 95, is it? 4.7 again. 95. Looks to be 4.7. Let's get the manual. 95 is another 4.7. So we'll go for a little walk and get another 4.7. I'll tell you what, we'll take this out first. Where is it? So that was 96. 95. That one. Yep, 4.7. Right, I'll go and get another. Right, that's gone for another little walk. So we'll get that the right way round. So if it isn't this, the next thing we're going to do is change the chip. Say if you don't change these and you change the chip and it fixes it, and then these capacitors are leaky, and so you send it back and 3 days later the chip's faulty again because these were causing load issues. Right, we'll switch it back on. And we still have no audio. Right, we're going to probe around the chip and then we're going to change it. So, I think we said pin 1 was the input. Certainly getting nothing there. So, Mike's going in there, and we've coupled the coupling capacitor there, the coupling capacitor there, so it comes out of pin 1, goes into pin 5, comes out at pin 7. So I put my screwdriver on pin 7. There's nothing between 7 and the deviation control really, unless there was a broken track or wire missing or something like that. So the fact we can make it click, well, we're now on PA, aren't we? So I'll just get the chip changed, and it's a JRC one. We've got. Funnily enough, that's what we've got in stock, because when we changed it in the CB2700, which is actually the one which went back and the customers done that meter modification to, we'd only got JRC ones, which are a bit posh. I know you can buy generic ones for pence, but I think the JRC ones are 147. This is going to be fun to get out. We'll probably end up cutting it out. The pins are bent over as part of the original assembly. So try and kind of unbend them with the soldering iron. Otherwise we'd have to cut them off. I think they should yank out now. Probably won't come out in one piece, but who's bothered? I think that bottom left one slightly got left behind. Yep. I mean, these aren't the best quality boards. Got to be quick. Right, I've got chips in yet another room. I'll go and get one. There we go, genuine 4558D from JRC. So all we've got to do is put that in the right way round. These aren't static sensitive. if this doesn't work, we'll have to start looking about is the wiring from the mic socket faulty. We'll do them in likelihood of culprit order. There we go. You know what, I'm going to try his microphone just in case our test mic's faulty. No, let's go to CB, check there's nothing. 1 2 1 2. No, there's nothing. Right, so another approach. So once again, there's no point in checking microphone wiring if I can't make pin 3 make it hum. So we'll stay in CB mode for a bit. I'll put it in low power. So pin 3 is there. There's nothing there. So pin 3, the one which is the output, we already said I think was pin 1. I'll just check with the other diagram. Yeah, it's pin 1. So the output of that section is pin 1. There's a bit more of something there. And then that goes into pin 5. Perfect. Now we didn't have that before. So we've got it half fixed. And then it comes out of pin 7. I wonder if it's being. What else can drag it down? We've done that. We've done that capacitor. We couldn't. No, we couldn't have a faulty deviation control because then it would work in PA. 1 2 1 2. Nothing in PA. So we're looking at what can drag it down. Because what else is there? I mean, that could theoretically drag down the input, but I don't think so. '98 could drag down the input too. 98 and 91. Just double check. Yeah, we'll do 98 and 91. I'll do these off camera, otherwise this video is going to be hours long. Okay, so we've got it back working. We'll take the opportunity to test his mic. So I don't know which one it was, but the final two we did. 91 and 98, 1 microfarad and 22 microfarads. So that was this one and that one, and it's brought back audio. So there we go. So now when I switch to PA, take his mic off again. It's nice to prove it kind of works. And we'll plug. Because Mr. Chippy's chewing at the bit to do it on the air test. We'll see whether we can do the squelch quickly, but I can do that later because it will work. Right, public address on. Testing 1 2, testing 1 2. And as ever, as I've always said before, you can't control the volume. It's always at full whack on this model, so that's fine. So I'll go through what we did. You saw that we did that capacitor, and then we've ended up doing all the four this side of the chip and the chip. Now the chip was definitely faulty because when I probed around at first, the second section we'd got no output, and we had output from the second section, and it was being dragged down by one of those. So there we go, we've got audio back. Isn't it funny though, the same customer, Murphy, got the same problem and the same chip. Right, back to where we were. So we were ticking things off our thing, but all this is time consuming. You know, that's another hour spent, isn't it? Where have I put the sheet? We need to do the VCO. I've gone and taken it in the other room, haven't I? Right, so VCO. Let's quickly do that. See whether the squelch has fixed itself, which can happen because those capacitors dragging down the voltage could have affected the squelch. Right, we want. Here we are. So on these, it's done on channel 40. And you're looking to transmit, so go to channel 40. Now it's never been touched, so I don't think we're going to touch it unless it's miles out. The fact it works on channel 1 and 40 without hesitation, it's never been messed with, which is great news. So we need an earth on here because it's floating, the chassis is floating. So which one's negative? That one. So we'll just make sure we've got 13 point something volts there, which we have. The test point, I know where the test point is, it's resistor, whatever it's called, just there. It's the one with the, is it that one? Yeah. So in transmit, they want on channel 40 for it to be 3.5 volts. It's 3.66, absolutely fine. But we've proved it. So that's that done. And then what you do, I'll go back to channel 20, check we're still on frequency. Yep. Plug our test gear back into the extension speaker socket. When I can find it. There it is. Helps if we put it into speaker and not PA. It's that one. There we go. So just go to the SiNAD meter because there's one more adjustment. And it's that coil 18. No, that coil 18. Because when I find my tool, I'll probably put the whole cloth back on top of the tool. No. Absolutely no idea where I've put the trimming tool. It's there. So we're now going to look at the SiNAD meter we'll just wind that down, make sure that that's in the correct position. They'd have you do it with an oscilloscope on test point 3, but we don't need to do that. If you're setting it up when the VCO had been messed with and it wasn't running, but the fact we've got audio coming through so beautifully, I don't need to do it with the oscilloscope on test point 3. We can just do it with the SiNAD meter, just check it's in the right position. It is. Didn't need touching. That now brings us to squelch. So as presented, when we turn the squelch down, with no signal, there was no hiss. Well, we've got that hiss, but we couldn't set full squelch. So, here goes. We still can't set full squelch. So we're going to have to, I'm going to have to do this. I'm going to do the on-the-air test first, and then we'll come back to the bench and we'll fix the squelch problem. But it's going to work all right on the test because we've already got, what sensitivity was it? It's 1.8, so it's not brilliant, but it will be okay. So as a temporary measure, because we've got to do the on-the-air test or it's another day, we'll put the lids on. I'm not going to connect the speaker, that would be kind of silly, so we'll do it to extension speaker only. And all we've got to do is sort the squelch out. Right, so I've not touched the deviation, so this will tell us what it was as presented to us. So put the glasses on for this. Well, actually it's 2, so nobody's wound it up. It's 2, so we'll just pop it on to 2.2 to 2.5. Voila. There we go. Back to putting the aerial on it. Put one screw in there. I started this, like 2 hours ago. I thought that's going to be, well, more than 2 hours ago. 4, 5, 6, 7, 3 hours ago. I know I had tea in between, but I thought, oh, that's going to be plenty of time because it only needs a tune-up, but it didn't, did it? So not quite out of the fire with it, but we're not far off. Right. Let's see what we can hear. We need the extension speaker plugging in. There we go. We need the aerial plugging in. One and a Roger. We're on low power. One and a Roger. Oh, the S meter needs setting. Because I wound it up, didn't I? There we go. That's spot on. I'll just pop one screw in and I hope I haven't missed Mr. Chippy. Put the aerial back in. Oh, when I saw that S meter all over there, turn the picture off, it is off. 19 Roger. They love swearing, don't they? The squelch will be adequate. As you can hear, it's opening fine, but it's just not as good as it should be. So I'll look into that when I come back. So we're not going to finish the video. We'll just pause it. Right, back to this. Well, we've done the on-the-air test now, so it worked really well, and despite my misgivings over the squelch, that worked really well as well. So we'll just do these two capacitors. I've looked at the circuit diagram. There's two capacitors, and I'm sure that will make an improvement, because it isn't normal for the squelch to be only 1.7 microvolt sensitivity. So it still worked fine, but I know that's not normal. So here we go. It's these two capacitors here in the squelch circuit. So when we look at the circuit diagram, we've got a capacitor, electrolytic capacitor there, I think it's 47, and we've got an electrolytic capacitor there which is I think 46 or 48. So we've got 48 there, it must be 48, and then we've got 47 there. So we'll get those changed. I think one of them is quite an unusual value for an electrolytic. It's 0.47 microvolts. We do have them in because of this type of set. It's a possibility that Fidelity 1000 Great chassis also have them. I'm really pleased with the on the air test though, it's exceptionally good. So the first one is 0.47, that's what I was talking about. And the second one .7. I think we've got a 4.7 on here, which I pulled out of stock for this purpose. On the other hand, I haven't. I'll put that back. Go and get 4.7 and 0.47. Right, get those in. Now, was there something I inadvertently unsoldered? I think I've dealt with it. We'll be going over this with isopropyl alcohol very shortly, but I want to see if this has improved the squelch or whether it's just the same, and that's the way it is on this particular set. But other than that, it's really exceptional. Checking that is a possible dry joint in the future. Right, here we are. So what do we need to do? We don't need to do anything except plug the speaker on the wall in. We don't need any test instruments for this. Extension speaker, is that the right one? That's PA speaker. Right. Power it up, plug the mic in. Make sure we're not on channel 31, which is what we are on. Back to the test equipment. Just come off the aerial. Already done the aerial demonstration, we don't need to repeat that. You know what, I was going to say I'll turn the soldering iron off, but I've got the speaker to connect. I found the eBay advertisement from where he's bought this from, and as he said, there's two wires going in the side here, and I just wonder whether they've at some time it's had an input to play music, and that's what's ruined the audio IC. Right, here we go. So I want squelch to full. Check it's still on frequency, it is. See whether we can actually... Yeah, it's fixed it, that's it. 100 microvolts. I'll show you the attenuator. So, you can see the left hand one, I'll just move the camera slightly. We want it to come into 100 microvolt, 1, 3, 10, 30, 100. There we are. So I don't need to adjust anything. It's at minimum squelch on the preset. It's on maximum squelch on the radio. And our squelch sensitivity is now what? So signal generator standby, parked at 0.3. Set the squelch on the radio to threshold. Yep, that's threshold. Fill some of this in as well. It's now 2.2 to 2.5 kilohertz. VCO was 3.6 volts. That's fine. You can't alter that. And we've now got 100 microvolts instead of never opens. And let's see what we've got. Signal generator back on. 0.98. I said it's always under microvolt. 0.98 microvolt. So there we go. But we did this on the air test with it at 1.7 microvolts. But it worked. So the switches work, potentiometers work, the sockets work, the PA now works. The mic and the speaker, I've ticked that off before doing it. So we've also done capacitor, is it 40, turn the volume down, 47 and 48. I think they've been playing music through this probably 30 years ago. And it's 0.47 microfarad and 4.7 microfarad. So we did all those. We did another one, I can't remember what, but it was 1 microfarad. 1, 2, 3, 4, 5, 6. That's it. 2 more there. Bob's your uncle. What a lovely set. Now I'm going to turn the power off and unplug the extension speaker. I just want to see which is the positive and negative on this speaker. It doesn't matter, but you know what, I just, with them using the same colour wire, all we need to do is to put this to ground. It's a total waste of 30 seconds, and see which one buzzes through. Not that one, that one. So that's negative. At least the cone will move the right way. I mean, this is only relevant if things are stereo, but you know, I just sometimes do things like that. Right, we'll go with the board with isopropyl alcohol. Put that lid back on. Well, he's ended up with such a lovely set. And he's cleaned it up a treat, because I can see the pictures on eBay, the state it was in. I'll just cut the power off, because you never know what's powered all the time. So I've been working around the audio processing there. Not only does it tidy it up, it enables you to look for things like dry joints. If it's all nice and clean. There's nothing, where he's done the synthesizer, you know, there's a capacitor just there, he's done that. So we've already had it on the aerial, we don't need to repeat that exercise. Well, I've never had squelch being iffy before, so there you are. You don't need to watch me put all these screws in. So that's it. We'll draw the video to a close. We'll end up with full 4-watt output, exceptional performance. We can unplug everything. Thanks for watching. Interesting repair. Uniden Uniace 100 with no transmitted audio and insensitive squelch. Thanks for watching.